Hi, welcome back to Mr. Chemistry. This is Lewis structure lesson number 10. Lewis structure represents the number of valence electrons around each atom in a compound structure. Remember that an unshared pair of electrons, when they're being shared, is going to be a dash, okay? Hybridization, things that count are unshared pair of electrons and dashes. Also, when you do hybridization, don't forget that S has 1, P has 3, D has 5, and F has 7. Okay, and when you want to know that the structure is the best possible structure, use formal charge. Formal charge is Fc equals VE minus NBE minus BEP. Valence electrons minus non-bonding electrons minus bonding electron pairs. Okay, so let's go ahead and get down to business. I'm going to cross out that 1 there. Fluorine, because it's in group 17, it tells me it has 7 valence electrons. And we're looking at the oxygen here. It's group 16, so it has 6 valence electrons. Now, our oxygen is going to be our core atom because it has 2 docking ports, but fluorine only has 1 docking port. So now we're going to put oxygen in the middle, and we're going to put an F on either side. First thing you want to do is you want to connect the oxygens to the fluorines. Okay, then you want to give fluorine its octet. Now I want you to notice, I did this without trying to figure out how many valence electrons are, because I can look at this and just do this by sight. But if you want to do it the other way, that's fine. So F, we have 2 of those, and each one has 7 valence electrons. Oxygen, we have 1 of those with 6 valence electrons. And so this is going to give me 14 valence electrons and 6 valence electrons, which gives me 20 valence electrons. All right, so far we've used 16, right? Now the question is, would we put a double bond on either side? And would that be the best possible structure? Well, we can't do that. And the reason why we can't put a double bond, like, why can't you just go and do this and call it good? The problem is fluorine violates the octet rule. And it being a period 2 element, you can't violate the octet rule with the period 2. So you actually can't do that structure. So automatically you know that that's a bad thing to do. So we're going to have to leave it like this. Okay? But oxygen also needs its octet. We got 16, so we're going to put 2 here. That makes 18. And 2 here. That makes 20. All right, let's see if this is the best possible structure. Let's see if everything works out. So we go formal charge of our oxygen first. Oxygen came in with 6 valence electrons. It has 4 non-bonding electrons and 2 bonding pairs. So that gives me 6 minus 4 minus 2, which is 0. That's really good. Let's do the formal charge for fluorine. Okay. That came in with 7 valence electrons, 6 non-bonding electrons, and 1 bonding pair. And that gives me also a 0 there. Well, that proves that this is the best possible structure. Well, listen, you guys be snarly. I will see you back here at Moosine Chemistry.